Hi students, welcome to Samveda E-class, 7th standard mathematics, first chapter integers, third session. In the second session and first session you already discussed about integers and their properties of addition and subtraction. In third session or last session we discussed about the multiplication of integers. The multiplication of integers. In third session we discuss about multiplication of integers. What is multiplication? The multiplication means in mathematics multiplication is the addition of equal size group is known as multiplication. It is also called as repeated addition. This is the multiplication. One example, 4 multiplied by 3, it is written as 3 into 4 and spoken as 3 times 4. 4 into 3 means 3 times 4 can be calculated by adding 3 copies of 4 together. 3 into 4, that is equal to 4 plus 4 plus 4. How many times? 3 times. Very good. Is this equal to 12? Here 3 is the multiplier and 4 is the multiplicand or the factors and 12 is the product. 3 and 4 are the factors, 12 is the product. You know that? Next, therefore, the simplest form of addition is a multiplication. The simplest form of addition is multiplication. Next, what is the question? Can we represent addition of integers in same way? Let us learn how to multiply integers. Multiplication of a positive and a negative integer. Take positive and negative integer. Example, minus 4 is an integer. Minus 4 is multiplied by 5. It is written as minus 4 into 5 and spoken as 5 times minus 4 can be calculated by adding 5 copies of minus 4. Okay? That means minus 4 plus minus 4 plus minus 4 plus minus 4 plus minus 4 5 times is equal to 5 into minus 4, that is equal to minus 20. See the number line. Is number line is 0, minus 1, minus 2, minus 3, minus 4, etc. This is negative integers number line. Okay. Minus 4, 0 to minus 4. How it goes? 0 to minus 4, first one. Second one, 4 to once again minus 4, that is minus 8. Minus 8 plus minus 4, that is minus 12. Minus 12 minus 4, add minus 4, that is minus 16. Then minus 16 plus minus 4 is minus 20. Yes, very good. Minus 20 is the answer. Here, how many times is 7 is given here? 4 times 7 is given. Minus 7, minus 7, minus 7, minus 7. 4 times is there. How to written it? That is 4 into minus 7. 4 times minus 7. 7 4s are 28. Plus into minus, minus, that is minus 28. Let us find 3 into minus 5 in a different way. First we find 3 into 5 and then put minus sign before the product obtained. Then we will get minus 15. Then we find minus of 3 into 5 to get minus 15. Similarly, 5 into minus 4 is equal to minus of 5 into 4. Minus comes before the product. Okay, observe it. Then minus 20. Okay. Next, we thus find that while multiplying a positive integer and a negative integer, we multiply them as whole numbers and put a minus sign before the product. We thus get a negative integer. Now, we multiply an integers as positive integer into negative integer, then we get negative integer. See here, plus into minus is equal to minus. That means positive into negative is equal to negative. Next, first we done positive to negative. Now we go to negative integer to positive integer. We first find minus 3 into 5. Minus 3 into 5 means, observe the following pattern. Here 3 into 5 is 15, good. Then 2 into 5, 10. What is the pattern here? Observe, 1 is less than 1, that is 5 is less. In first 15, second is 10, that means 5 is less. This is 10 means 15 minus 5, we get 10. This is 15, the 15 minus 5 we get 10. Then 10 minus 5 is 5, 0. 5 minus 5 is 0. Okay. Then similar, minus 1 into 5, here it is given dash, because we do not know the answer. That is why, what is the pattern here? Subtract 5 previous answer, that is 0 minus 5 is minus 5. What is the dash filled by? Minus 5, very good. Next, minus 5 is the answer, minus 5 minus 5, that is minus 10. What is dash filled by? Minus 10, that is minus 2 into 5 is minus 10, very good. Next, minus 3 into 5, that is minus 10 minus 5, that is minus 15, that is what is the dash filled by? Minus 5 into, sorry, minus 3 into 5 is equal to minus 15. Next, we already have, what is that? 3 into minus 5 is equal to minus 15 in previous. Okay. Now we get minus 3 into 5 is equal to minus 15 is equal to 3 into minus 5. Okay. That is commutative property, like, very good. Next, what is the pattern here? 15, 10, 5, 0, minus 5, 0, minus 5, minus 10, minus 15. See here, 10, 15, 10, 5, 0, minus 5, minus 10, minus 15, etc. Okay, you know this pattern. Next, using such patterns, check whether minus 4 into 8 is equal to 4 into minus 8. 4 into 8 means 32. 32 to minus 32. What is the pattern? We go 32 to minus 32. 4 into 8 is equal to 32 minus 8 is 24. Next, what is the pattern? 24 minus 8. 24 minus 8. Pattern, observe the pattern here. That is 16. 16 minus 8, 8. 8 minus 8, 0. 0 minus 8, minus 8. Minus 8 minus 8, that is minus 16. Minus 16 minus 8 minus 24. Minus 24 minus 8 minus 32. Then we get minus 32. The pattern is 32, 24, 16, 8, 0, minus 8, minus 16, minus 24, minus 32. In general, for any two integers a and b, can we say that is a into minus b is equal to minus a into b, that is equal to minus of a into b. The minus is before product, that is in signs general. In generally sign, minus into plus is equal to minus, any two symbols. Minus negative integer into positive integer is equal to negative integer, very good. Next, the multiplication of two negative integers. Okay, we take only negative integers. Can we find the product of minus 2 and minus 3? Can we find the product of minus 3 into minus 2? Observe the following. Minus 3 into 4 is minus 12. We know that. Next, minus 3 into plus 3. Plus into minus minus. 3 3 is the 9. That is pattern. What is the pattern? Minus 12 minus 3. Minus 12 minus 3. That is minus of minus. That is minus into minus plus. Minus 12 plus 3 means minus 9. Okay. Next, minus 3 into 2, that is minus 6, minus 6, that is minus 9, minus of minus 3, that is minus into minus plus, plus 3, minus 9 plus 3, that means minus 6. Minus 3 into 0 is equal to 0, that means minus 3 minus of minus 3, that is equal to minus 3 plus 3, that is also equal to 0. Next, minus 3 into minus 1, answer we do not know, but pattern we know that pattern. 0 minus of minus 3, that means 0 plus 3, 0 plus 3 means 3, that is minus 3 into minus 1 means plus 3. Okay. Next, minus 3 into minus 2, you go to pattern, that is 3 minus of minus 3, that is equal to 3 plus 3, that is 6, that is minus 3 into minus 2 is 6. Very good. Next, do you see any pattern here? Yes. Do you observe any pattern here? Observe how the products are changed here. Based on this observation, complete the following, that is minus 3 into minus 3 is both side minus. Okay. That is why 3 3 is a 9. According to pattern, minus converts to plus, that means plus 9. Similarly, minus 3 into minus 4, 4 3 is a 12, sign is positive. Then what we decide? So, observing these products, we can say the product of two negative integers is a positive integer. We multiply the two negative integers as whole number and put a positive sign before the product. Okay. Thus, we have minus 10 into minus 12 is equal to plus before product, minus plus sign before product, that is 120 before plus. In general, any two negative integers a and b, we say that minus a into minus b, that is plus a into b before product, plus sign is there. In symbolically or general, minus into minus, that is plus, negative integer converts positive integer. Next we go to product of 3 or more negative numbers. We observe that the product of two negative integers in previous. Okay. What will be the product of 3 negative integers and a 4 negative integers, etc. That means 5, if there are 5 negative integers, there may be 6 integers, 6 negative integers, then what happens? Let us observe the following examples, that is minus 4 into minus 3, that is plus 2. We know 2 negative integers multiply, then we get positive, that is plus 12. Then we take 3 negative integers, minus 4, minus 3, minus 2, 3 negative integers, here also minus, here also minus, here also. We grouped it, first we grouped it. How? The minus 3 and minus 4 are grouped, that means first we multiply minus 3 and minus 4, then after minus 2. Okay. Then minus into minus plus, 4 3 is a 12, then into minus 2, that is plus into minus, positive into negative, already we done it, plus into minus means minus, 12 2 is a 24. Okay. Similarly, if you get 4 integers, 4 negative integers, minus 4, minus 3, minus 2, minus 1, then we grouped 3 negative integers, because already we know the values of 3 negative integers, that is minus 24, minus 4, minus 3, minus 2, minus 4, minus 3, minus 2 is this value is minus 24. Okay. Then minus 4 into minus 3 into minus 2, the value is minus 24 into minus 1. In previous, minus into minus plus, 24 ones are 24. Okay. Next, if you have 5 negative integers, then minus 5, minus 4, minus 3, minus 2, minus 1. There are 5 negative integers. We grouped here 4 negative integers, which are there, minus 1, minus 2, minus 3, minus 4. The value is plus 24 into minus 5, that is plus 24 into minus 5, that is equal to plus into minus minus 25 5s are 120, that is minus 120. What we observe here? From the above products we observe that the product of two negative integers is a positive integer. Next one, the product of the three negative integer is a negative integer. Observe, two negative integer positive, three negative integer negative. If four negative integers, the product of four negative integer is a positive integer. If the product of five negative integer is negative. Symbolically, the sign multiplication, we know plus into plus, plus, plus into minus, minus, minus into plus, minus, minus into minus, plus. This is very important, sign multiplication. Okay. We observe this one and this one very carefully. Next, we find that if the number of negative integers in a product is even, then the product is a positive integer. If the number of negative integers in a product is odd, then the product is negative integer. If in the problem there are negative integers are in odd numbers, then the answer is negative integer. First one, closure property, closure under multiplication. Observe the following. What is here? Minus 20 minus 5, that is 100. The product is an integer. Yes, 100 is an integer. Next one, minus 15 into 17. The multiplication of these two is minus 255. Minus 255 is a integer. Yes, product is an integer. Next, minus 30 into 12 dash. What is the multiplication of these two product is? That is how much? 360. Which is 360? Plus into minus minus, 12 zeros are 0, 12 3s are 36, that is minus 360. Minus 360 is an integer? Yes, product is an integer. Next one, minus 15 minus 23, minus into minus plus 23 into 15, that is 345, is an integer? Yes, product is an integer. That is why what we observe here? Can you find a pair of integers whose product is not an integer? No, all are integers. Then the product of two integers is again integer. So, we can say that integers are closed under multiplication. In general, for all integers a and b, a into b is an integer. Commutative property of multiplication. We know that the multiplication is commutative for whole numbers. Can we say multiplication is also commutative for integers? Next we find it. Observe the following and complete it. Here, see the table. First statement, 3 into minus 4, that is minus 12. Second statement, interchange the integers. Minus 4 into 3, that is minus into plus minus, 4 3 is a 12. What we observe here? Both are equal. Check here. Minus 30 into 12, that is minus 360, interchange. Then 12 into minus 30, that is also minus 360. Then these two are equal, two statements are equal. Next, minus 12 minus 35, that is minus into minus plus 12 into 35 means 420. Interchange the minus 35 into minus 12, minus into minus plus, that is 420. These two are equal. Then these two statements are equal. Minus 70 into 0 is 0. Next, interchange 0 into minus 17 is also 0. Then these two statements are equal. Last one, minus 1 minus 15, minus into minus plus, 15 ones are 15. Change the interchange, that is minus 1 into minus 15, minus into minus plus, 15 ones are 15. These two statements are equal? Yes. What we observe here? The above examples suggest the multiplication is a commutative for an integers. Okay. Next we can say that integers are commutative under multiplication. In general, for any two integers a and b, a into b is equal to b into a, that is commutative under multiplication. Next, multiplication by 0. We know that any whole number then multiply by 0 gives 0. Observe the following products of negative integers and 0. Minus 3 into 0 is 0. Yes. Next, 0 into minus 4 also 0. Minus 5 into 0 is 0. Okay. 0 into minus 6, that is also 0. What we observe here? This shows that the product of a negative integer and 0 is 0. In general, for any integer a, that means a into 0 is equal to 0 into a, that is equal to 0. Multiplicative identity. We know that 1 is the multiplicative identity for whole numbers. Check that. 1 is the multiplicative identity for integers as well. Check. Observe the following products of integers with 1. Minus 3 into 1 is minus 3, 1 into 5 is 5, and 1 into minus 6, and 7 into 1 plus into minus minus, 6 ones are minus 6, plus into plus plus, 1 sevens are 7. Next, this shows that 1 is the multiplicative identity for integers also. Okay. In general, for any integer a, we have a into 1 is equal to 1 into a, that is equal to a. Next, what happens when we multiply any integers with minus 1? Minus 3 into minus 1, how much? Plus 3, because minus into minus plus 3 ones are 3. 3 into minus 1 plus into minus minus, 3 ones are 3. What you observe here? Both are equal? No. Can we say 2 minus 1 is a multiplicative identity of integer? No, because they are not equal. 0 is the additive identity, whereas 1 is the multiplicative identity for integers. We get additive inverse of an integer when we multiply minus 1 to a. We get their inverse. When we multiply minus 1 to integer or a whole number, then we get their inverse, not identity. Okay. Take one example. A into minus 1, that is minus a. That means minus 1 into a, that is also minus a. The additive inverse of a is minus a. Additive inverse of minus a is plus a. Associative property of multiplication. Here consider minus 3, minus 2 and 5 are integers. 3 integers are given here. So, we get the same answer in both the cases. Thus, big bracket minus 3 into minus 2 into 5 is equal to minus 3 into big bracket minus 2 into 5 is equal. That means the product of 3 integers does not depend upon the grouping of integers, and this is called the associative property for multiplication of integers. In general, for any 3 integers a, b and c, that means a into b into c, a into b into c, distributive property. Next one is distributive property. In distributive, we know that the distributivity of multiplication over addition of whole numbers, already we know that. Okay. You go for integers. 16 into 10 plus 2 is equal to 16 into 10 plus 16 into 2. See here, 16 into 10 plus 16 into 2. This is distributive property. Let us check if this is true for integers also. Okay. Observe the following. What we observe here? Can we say that the distributivity of multiplication over addition is true for integers also? Yes, it is true. The distributivity of multiplication over addition is true for integers. In general, for any integers a, b and c, that is a into b plus c is equal to a into b plus a into c. This is called distributive property. Next, we can say distributivity of multiplication over subtraction is true for integers. We will check. Okay. For subtraction, we will check it. One example, 4 into 3 minus 8, subtraction is here, is equal to 4 into 3 minus 4 into 8. The distributivity of multiplication over subtraction is true for integers. In general, any three integers a, b and c, a into b minus c is equal to a into b minus a into c. Okay. How to make multiplication easier? Can we find minus 25 into 37 into 4 as, which one is the easier? Why? The second way is easier because multiplication of minus 25 and 4 is gives minus 100, which is easier to multiply with 37. Note that the second way involves commutativity and associativity of integers. We find that the commutativity, associativity and distributivity of integers help to make our calculation simpler. Why we know these properties? Because of calculation is simpler, make calculation simpler. Next, let us further see how calculations can be made easier using these properties. Find 16 into 12. 16 into 12, it can be written as 16 into 10 plus 2, that is 12, 10 plus 2, that means 16 into 10, 16 into 2, that is 160 plus 32, that is 192, very easy. Okay. Similarly, minus 23 into 48. These are the integers multiplication properties and their meaning. Next, we go for division of integers. Division of integers, we know that the division is inverse operation of multiplication. What we observe here? We observe that, so we can say that when we divide a positive integer by a negative integer, we first divide them as whole number and put a minus sign before the quotient. For any positive and negative integers a and b, a divided by minus b is equal to minus a divided by b, that is minus of a divided by b, whereas b must be not equal to 0. This is third session completed, last session. You have learned that what is the meaning of integer, integers addition, subtraction, multiplication, division and their properties. Homework. Thank you, students. Have a good day. Be safe. Keep learning always.